I am Albert Einstein, standing now in front of the Princeton University Library. The crisp, quiet air of this place seeps into my being. Through the large windows, I spot the papers, filled with equations and theories, the fruits of my lifelong intellectual pursuits, my works on relativity and quantum physics. They lie there, neatly arranged on the shelves, labeled in a familiar yet somewhat distant way. I press my hand against the glass, as if trying to touch the very essence of the ideas that once burned bright in my mind. I was a physicist, a seeker of truth in the vast cosmos. Princeton, this haven of knowledge, was where I spent many years delving deep into the mysteries of the universe. These papers, they are not just ink on paper. They are the manifestation of my struggles, my breakthroughs, and my unwavering belief in the rationality of the universe. I remember the countless hours spent scribbling equations on blackboards, the sleepless nights filled with the pursuit of a unified theory. The theory of relativity, both special and general, was a revolutionary concept in the annals of physics. It challenged the long-held Newtonian view of space and time, introducing the idea of space-time curvature and the equivalence of mass and energy, encapsulated in the famous equation E equals mc. In the early 20th century, the scientific world was in a state of flux. The classical physics that had dominated for centuries was showing its limitations. The discovery of quantum phenomena was shaking the very foundations of our understanding. I was driven by a desire to find a more comprehensive theory that could explain both the macroscopic and microscopic worlds. The special theory of relativity, proposed in 1905, was a bold step. It postulated that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is constant. This was a radical departure from the Galilean relativity that was prevalent at the time. The general theory of relativity, developed later, was even more profound. It described gravity not as a force in the traditional sense, but as a curvature of space-time caused by mass and energy. This theory was able to explain phenomena such as the precession of Mercury's orbit, which had puzzled astronomers for decades. It was a triumph of human intellect, a leap into the unknown. Now, I stand here, looking at these papers that have become part of scientific history. Students and researchers come and go, poring over these works, trying to understand the ideas that changed the world. But sometimes, I wonder if they truly grasped the spirit behind these theories. The equations are just a means to an end. The real essence lies in the philosophical and scientific revolution they sparked. The world has changed so much since I first put pen to paper. Technology has advanced at an astonishing pace, and yet there are still so many mysteries left unsolved. The problem of unifying quantum mechanics and general relativity, the so-called theory of everything, remains elusive. These papers, although they have inspired generations of scientists, are like a map that only shows part of the vast territory of the universe. As the sun begins to set, casting a warm glow over the library, I know that my time here is limited. The ideas I left behind will continue to shape the future of science, but the journey is far from over. The pursuit of knowledge is an endless quest, and these theories are but milestones on this long and winding road. My spirit is filled with a mix of pride and a sense of unfinished business. Slowly, I turn away from the library, walking into the fading light. Behind me, the papers remain, a testament to the power of human thought, a reminder of the endless possibilities that lie within the realm of science.